Welcome back. In today's lesson, we're going to talk about continuous function. Continuous functions as calculus looks at it. We have three different parts to the definition of a continuous function. We'll see that the function, call it f, is continuous if the following conditions are satisfied. Number one, wherever the critical number is, f of c must be defined. The second thing is that the limit as x approaches c of the function f of x must exist. And the third part says that f of c, the first one, has to equal the limit as x approaches c of f of x, which is the second one. So say we had a graph something like this, where you had a line, you had a hole right there, line continued on, and this is our value of our critical number c that we're looking at, and then let's put that point just above that line. That would not be continuous, and the reason this is not continuous is because f of c does exist. The limit as x approaches c, that also exists, but they're not the same. So this, the second part or the third part of the definition of a continuous function would be rejected. There are three different types of discontinuity that we look at. And the discontinuity that we look at the types of discontinuities that we look at are a point. That's similar to what we were just seeing on my previous example, where let's say you had something like this, where you had a line, we had a circle, then we had a line there, and then we had a point up here. Oftentimes that point is called removable discontinuity. Sometimes it can be removed, sometimes it can't. We have jump discontinuity, where you have like an absolute value graph. It comes over, has a hole in it, jumps up to here, and keeps on going. And the third type is infinite. And with infinite discontinuity, we're taking a look at like a vertical asymptote. So say we have an asymptote. Sorry, I'm squeezing this in here a little bit. Approaches from that side, and then, you know, maybe does something like this on this side. So we have an infinite break in the graph. The reason why we look at the definition of a continuous function for calculus is because the AP folks, and many times you'll see this in questions, like to ask us where the derivative exists in our next unit when we're talking about derivative. Where does the derivative exist? Where does it not exist? And where anytime you have a function that's discontinuous, it would not exist. So if I were to have, say, a function something like this. Let's take this one. This is kind of a popular one that I see a lot. F of x equals the absolute value of x minus 1 over x minus 1. And that has some discontinuity at 1. You can't divide by 1. Over to the left of 1, that function is negative. And over to the right of 1, that function is positive. So that has jump discontinuity. And down the road, when we start talking about derivatives, what's going to happen is that you're going to find that the derivative of this function does not exist right at 1. And that's why we look at discontinuous functions. And it fits in here with our limit stuff because that is the part of the definition of a continuous function. The final part of this lesson is called the intermediate value theorem. And the intermediate value theorem is more just some common sense. It says that if f of x is continuous on an interval from a to b, and there exists a value, say w, that's what our book calls it, between f of a and f of b, then there exists a value c such that f of c equals w on the interval between a and b. Basically what this says is that the a to b is our x intervals. F of a and f of x, f of a and f of b are the y values associated with that, and that the graph has to push through all. If it's continuous, it's got to go through all the values between f of a and f of b along the way. Let me draw you a picture. You'll like it more. Let's say we had a graph something like this, and the graph went from here, and say it went to there. And let's say that on this interval, I'll let that be b right on the x-axis, and I'll let this far point be a over here. And that's continuous on that interval. So now anywhere between the points a and b, this point right up here is f of a. This point that appears to be at 0 is f of b. And let's say w is in between there. Let's say let's say my point w is right here. What it's saying is the graph has to pass through w on its way to f of b, and that there is just a value c such that f of c equals w. That's it. It's common sense. You can't go from 1 to 100 without going through 2. That's all it's saying. Okay? So you're ready to do some stuff on continuous functions, and remember the importance of this is that eventually down the road, where functions are discontinuous is going to be where part of what you can't find the derivative at that particular point.